Hello, welcome to another video. Um, Last time we left off implementing the read instruction. I've added a few things since then. I've added ability to have like traces, and also like just kind of minor stuff for help aiding debugging. A few different opcodes and whatnot. And yeah, different like traces, ability to do debugs. I found there was actually a bug in the instruction parsing for jumping to an offset. It wasn't actually doing the signed part quite right, so I had to do that a bit interestingly. And yeah, so at this point here, I guess I will show you that kind of weird thing in instruction. Do that and offset. In fact, I can just search transmute. So now it has to do like quite a strange casting situation, um, where yeah, you can't set the top bit of an i16 because it's like, nah, that can't, because the 0b11 literals, I think, under the hood kind of generate an unsigned integer, and I can cast that to a u16 or I can cast that to an i16 depending on whether it has 16 bits or 15 bits for the i16. Found that out. So if you actually shift 1 up to up 14, you'll be setting that top bit, which if you just cast to an i16, it's like, nah, can't do that, can only go up to 35,000 or whatever it is. And so you have to use this transmute keyword to kind of force the cast, and have it as a U16 first and then force the cast. So then it will be like, cool, that is a valid I16 and it is negative, importantly. And yeah, here the kind of storing the individual bytes in an i16 is legitimate because it will just take the unsigned quantity and have it as a positive I16, and you would never have a negative I. You would never have a -1 here. You might actually have a -1 here, which it will probably, yeah, I think it does a runtime error, which is kind of frustrating. So if that ever happens, this one here might have a runtime error. I might just throw a comment, something like uh, the cast to I16 may have runtime error if I'm not sure what happened there. Top bit of um, byte is set? Question mark. Not really a great thing to do, but yeah, maybe I will just commit that up now. Had comments about instruction branch set when negative. That's probably good. So yeah, I guess I didn't actually introduce this. We're working on Odin's, which is an interpreter for the Z machine. 5 minutes in, haven't introduced it. So what was happening here was the instruction encoding his branches. So it's kind of a weird thing. It's either 1 or 2 bytes. I talked about this in a previous video, I'm not sure which. Basically, if bit 7 is... Interestingly, he didn't... because this is like another guy that's kind of taken the original spec and kind of annotated it. And he sometimes does diagrams for headers. But here he hasn't for these 2 bytes. But basically, if the top bit is clear on the first byte, then condition is for, oh no, if the 6th bit, second and top bit is set, then it's 1 byte only and it's 0 to 63. But if it is clear, then it's a signed 14-bit number. I wonder if it is clear, then it's a signed 14-bit number. Yeah, I actually wonder if this will, like, what if we have something like this? Format dot bring by I16 of 0x. I mean, we can just have ff, which should be -1. And I wonder if that will do the trick. And we'll just put that main there and see if that that is what I want. No, just that, so it doesn't have too much thing. So it has 255 there, which is correct. That is what I was testing. So I don't actually want that. Something like that. So I made a commit. Yeah, that's the right commit. And I think I'll push this here just because I'm playing around with Git stuff. I won't push this here. I'll push it afterwards. But what I wanted to show you is basically this is currently kind of working. We can have a kind of look around here. We can go north. We could go north again. And then we hit like unimplemented opcode, which we can implement that. And you can see here that it's like fetching the right rooms, and these are the right rooms that would happen if you did that. And if you say like go south, it goes a different way, and here it does that. And you could probably try and go around the house to the east. Maybe you could even try and open the window. You can't, but that's a different opcode that it's complaining about. These first two were the same. And like maybe you could open the box here, and that's a different one. That's the same kind of thing. So opcode 17 will probably be something about changing the property or an attribute of a thing or something in a function it's doing something around that. One thing I did notice that was a bit concerning that I'd probably want to visit sooner rather than later, aka now, is say if we go north, then west again. It's kind of hung doing something, and if we do like a trace of the interruptions, if we go north, then back west again, you can see it's doing something that looks kind of like an endless loop. And what it's doing is it's getting the sibling of L03, which I would guess is like it's trying to like looking through this function before, it you get the object you I think it's called cretin and the actual input the game. The object u is put into the current room, and so you will have a sibling theoretically of the next object in the room, which will probably be a the mailbox in this going back to the West Room case. And yeah, so what is happening here is it's kind of getting the sibling of the same thing over and over and over. So it's like it hasn't found the end of the list. And what I thought I'd do is have a look at machine dump, which is something that's chucked in there at the start of execute. Execute and down here. So it does this machine dump, and it basically does a dump of the current machine. And the idea of this was to kind of show the be able to kind of I killed them. I don't often do that. I usually have two terminals, but that's all right. I can restart it. So I write this machine dump, and one thing I notice straight away is the cretin object has it's number 4, but the sibling object is number 4. And the parent object, I guess, is 180 is the right thing. Where was it? Just there. It is the west of house. And the child object is me. And what is interesting is the mailbox is in there, but for some reason, the put property hasn't actually updated the thing correctly. So I think I want to actually, if we kind of start up them and maybe go to execution and like there was a specific opcode. Well, it's like move, uh, move, uh, object will just be everywhere. Insert object, that's the one I was looking for. So here we should be able to, after every insert object, I just want to like actually just crash. Which I wonder what I can do. I can do just something like unimplemented. It won't actually do it after every one. What I could do, I don't know. That's probably good enough. And here we can see the first one and then have a look at the machine done. I probably want to come on format print f line inserting %d and that is %f. And what are we doing it into? And we're probably just shoving it to another D, which is %s. And these can be object and object dump. And here we can just replace object with destination and actually no, undo that, do it again, something like that, and do something like that. But I wonder if they will actually work. No, it won't. So I think well, actually I can do come on. That might be a bit better. And do that. All in the name of debugging. Right, so we're moving Cretin into rest of house. And if we look at our machine dump, I think that has not done the right thing. No, because we want to do machine dump just after. So before we have, well, actually, what I can do is um, because we have, I think I want that and this, and it's not 3, but there, 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 and there. And this window we can open up object just to see what functions we actually have available. We have sibling, yeah, so we have all three. So before So sub will be D parent is not Chile. Something like that, and this will be objects sibling, and this will be machine and objects. Parent and child, and all of that can get finished, and all of that can actually go there, and this we can have that same s no object destination, but maybe do that. Yeah, had faith in myself. So I guess here I can do just this and see what kind of happens. So we show what it is before, but we never actually show what it is after. Do do something like this. Probably do something like this. And probably do something like this. Cool. So now, maybe, we can do the same. Cool. Do the same. Do the same. Do that. Do that. Just to make it a bit more concise. But without that and without that. Right, so here we have Credin doesn't have any siblings, so insert object should take the Credin object and put it inside of West object. And after the operation, the child of D, which is the destination, is the object, and the sibling of object is whatever was previously the child of D, and all children of O move with it. So I think what the issue here is, I'll need to be quick on the old Control C. When we go north, we're moving Crescent to the north of house. So I guess here the parent is 180. Not sure why the after had that, because we do that still. That's all right. So we're moving the Cretan into the north of house. So here, like the 180, we kind of lose the fact, and I think in the thief is like just it's doing a thing. Right here. Yeah, so West of House had a child of 4. So I think what's kind of happening is it doesn't kind of say in this. You kind of need to does this have like kind of an object tree type thing? It doesn't really. So what the object tree kind of looks like, I realize we don't really have this nice and big. So each object you have kind of 3 things. You've got the child, which is basically going to be some other object. We'll call it OG2. And you also have a parent, and you also have a sibling. So what that kind of means is you can have kind of trees like this. So you have like the maybe grandparent, and not that one, this, and that has some parent, and this might have like your aunt, uncle, and this may even have like your great uncle, aunt, something like that. And here you'll have you'll have maybe child, um, and your sibling. And maybe you are getting kind of inserted into the parent. So you have like a u slash create an object, and maybe this is gonna get inserted into the parent. So basically, you're going to be the first child of this, and your sibling is going to become whatever the child was. And all of these other children all point to the same parent, which may come in handy later. They don't talk to this point to that, but you can indirectly go there. And these one ways, I guess. But this is try and make it fancy, but yeah, so these are one ways, but these are kind of bi-directional, and I might show it for this one. This has something like this, and I don't know what a good arrow for. Oh, there might be. But what do I want to do? I want to go into that mode and do something like that. So these are one directional. In fact, I can probably do something fancy. Oh, I can just do 3x, do that. And yeah, I don't know. You get the point. And so at this point, it kind of looks like that. But say you are going to live with your great uncle, aunt, or something like that. In fact, maybe say you're going to live with like another family. You might have like, I don't know, like your godparent. I started writing it, but yeah. So say you're gonna move to the godparent, and you're gonna be their like kind of only person. What you need to do is kind of update these and you're basically going to lose your siblings and update that branch there. But the problem is we're never actually removing this from this hierarchy here. And what we really need to do is kind of delete us from there, which would require updating this branch as well as no, just that branch. I'm pretty sure. So what I think we need to do at this point is maybe go into this and see what happens. Um, do we not know where this is? We do know where it is. Not sure why it wasn't going. So we're already doing like all of this. So we're doing it like per version as well, which makes me think. Sorry, that's just going to be a blur of text. Yeah, so it makes me think that this might be better off. Kind of setting it up. So I guess maybe let's start with a comment of what needs to do. First, check if object has parent already. If so, check if object's parent's child is object. If so, then set object's parent's child to object's sibling. Otherwise, uh, find first. Well, get objects, parents, child, then loop. What are we looping over? Until the sibling is object, then set that child's sibling to be objects sibling. And that's kind of an unfortunate step where we have to do that loop. And that's purely because you only have a one directional, you can only see your next sibling in the line. You can't actually see the other way back, which would be like a weird family dynamic. But everyone can see the parent. So I think this is what I need to do, and once I've done that, I should be able to go north, then go back west again. That could still hit an issue with uh, yeah, it could still be an issue for um, like if there's another opcode that isn't done. So we might not be able to get another prompt. That's what I was going to say. Lost my train of thought, left the station. So I'm also kind of thinking, because this is kind of split into two halves for the two different versions of the two different kind of object trees, it could potentially be better to kind of abstract a lot of this out. To kind of just do that, all the magic for us. Yeah, what are we doing here? We're already doing something with our sibling. Update objects siblings parent to be object parent. It should already be the case, one would think. After the operation, the child of D is O, and the sibling of O is whatever the all children of O move with it. All children, but not all siblings. Yeah, I wonder what this is even here for. Um, we, hey, come on. Let's watch you struggle with them. Right, so yeah, we can get rid of that fine artwork. So here, if we go north and we go west again, still is doing the same thing, and that's kind of fine. Yeah, I kind of wonder whether this is actually needed. I'm trying to think. Fix me. is this needed? Because down the bottom of well founded this, it's the game's responsibility to keep the objects well founded. Because the way I kind of just described it before is everyone should already have the all my siblings should already all my siblings' parents should already be my parent. So I think that one shouldn't need doing. This one does need doing to make my sibling be yeah, my sibling should become whatever is the destination's child, and then I should become destination's child, and then my parent should become the destination. So I think this isn't needed. Uh, it should always be the case, but I think this is needed. And I wonder if I was kind of doing that to fix the thing I'm fixing at the moment. Um, in fact, it doesn't crash. I'm going to be bold and just delete some code. I could like do some blames to find out, get blame, object. It will all be me, but that's all right. And what 232? 232. So F10E7 get show F103. No, it was E7, wasn't it? And this was insert object. Yeah, so we did a thing and we just did the whole thing at once. I think I'm just going to be bold and delete those two chunks. It kind of does need to be in two sections easily, but this kind of check here. So we do need to see if we do have a parent. So I guess let's nut this out. Machine read bytes, and it's going to be machine, and it's going to be U32 of obj. We've just got obj parent, and the parent not equal to 0. Yeah, not equal to 0. We're gonna do a bunch of stuff. And what are we going to do? Um, Yeah, we could probably just do a machine read byte of machine, and do we like need to, yeah, we need to get the object address of things that we're doing. But we can do if object parent. Yeah, so this is kind of why I'm thinking, because we already have this parent child sibling. And I think potentially when I wrote that chunk of code in a video, I was saying it probably would be better to figure it out. So I guess here, yeah, we can do something like this out of that if scope, and we can just go object parent and pass it machine, um, and we can probably get rid of that. We can pass it the machine. Well, actually, if I'm going to be doing this, I should just do a quick sanity check. I don't know. Object parent, and this is going to be object parent of the machine and object number. So if we have a parent, if object parent, sometimes I wonder, if this not equal to 0, we're going to do a bunch of things, and those things are going to be object parent child equals object here. No, object child of machine, and this is going to be obj parent. And I guess don't need to do weird obj. So maybe I'll just replace that with object instead. And then we can do if object. No, I can't. It does have to be that. Otherwise, it would override that. So if obj parent child equal to object number, then that's going to be one case. Otherwise, that's going to be another case. And if that's that, we just want to go object set parent, and we're going to set the actually no, we're going to be what did I do there? I want to go there. We want to set the child to be my sibling. We want to set the child of the parent to be object sibling of machine objects. that is what we want to do. Is that what we want to do? So if we go up to the parent and we go down to the child and it is us, that means there's no one to the left of us, and so we just get the our sibling and make that to be the child, and so then we're kind of extracted out of that tree. That makes sense. So then the other case is we want to have something that we're like testing, which I guess we can call sibling, and what do we want to do? Well, we could just call it child. We don't have one of those in scope. We can have it set to obj parent child to start with. And I guess this can be a for loop. We do like a for loop over 3 lines. Find out. Actually, no, I want child to be declared there. And we're going to loop until the sibling of machine child. Well, we're going to loop until child not equal to 0, and the sibling of that is not equal to us. And we're also going to set child equal to object sibling of machine child. And I think I can just have an empty loop there, and that's just going to find that child that we want to set. And then we want to do object set sibling and machine, and we're going to set the child. And what are we going to set this to? We're going to set it to object. We probably just want to get our sibling here. So if we find, I don't know what I searched on there. All right. Do something like that. Yeah, I think that is kind of what I need to do. So I think at this point, it will probably complain. We probably need that. What doesn't like there? What doesn't I like there? Don't have this set chart. So I think here what I want to do is maybe also have this, I think this is the way we do it. Private equals file, and maybe do, yeah, set there, and maybe find that, and not Chile, U16. Right, and in this case, we probably want something quite similar to this. We probably don't need that as well. Which means we could probably do something like this. And yeah. Is that all we need? Yeah. And I think in that case, I'll probably come and replace this. And instead of returning something, we're going to write there, and we're going to write there. And the thing we're going to write is child. Child, something like that. And this won't be unreachable now. Cool, so sibling 5, sibling 5, and this one is 8. And here we probably want to just copy that whole thing and go what this, known one of these private equals file, and we probably want to go there and go set, and then go there, yep, and have sibling U16. It's almost like no, I want to do that and do something like that. Oh, and I want to do that and do something like that. And I want to get rid of one of those. And this is no longer unreachable. And here we want to do parent 4, and here it's 6. 6. And here, a lot of copy pasting in this one. Gosh, it's cold. I can feel like a chill on my feet. Probably some cloud coming in. That, yeah, and parents, and it's going to be 16. Not going to be anything returning. Something like that, and do another up here. Cool. And now just works. This removes objects from where it was in the tree. And if we do something like this, it still has some stuff that it doesn't know. That's because we probably do still need this just momentarily. Because I haven't converted everything else. Or we need to do something like that, and we'll probably need the same thing here, sibling, and probably the same thing here. Sometimes I do things the slowest. I find I do them more the slowest here. All right, it doesn't know object. Let's object number. Doesn't know dest. That's because we need to call that dest, and object. We need to call that destination number. Right, so now what I want to do is just run it and see if I can go north, and that still works. And if we go west again, we're in the Atlantis room. Oh no, that's the thief is getting moved about. Cool, that's fine. But yeah, we were there, and the west of house did have a child of 181, which is good. And then afterwards, we have a sibling of 181, and the house has it of us. Cool. So I think I fixed that one issue. We can like quit. We can kind of quit. That's kind of all right. So because of that, I can probably move this sort of code. I might make that as a commit, because what are we doing here? No, I don't want the debugging, but I will. That seems like it's got more going on with it. Right, so this one, I won't do that. I will do that. I will do that. I won't do that one. We'll do, won't, will, and won't do that. And won't do that. Yeah, I'll do that just in one commit. But this commit, removes redundant constants. And here in did it say insert OJ first removes object from tree. So it doesn't really say that, but we should. And I think I will kind of do this. So update object siblings parent to be object's parent, which it should just already be in insert obj. Don't set siblings parent to be up right there. It should already be the case. Right, so at this point we can run, so Odin run, we can go north, we can go west. We do have some debugging that will probably be good to get rid of. We can probably get rid of it here. Restore -p, and just all of that, thanks. And if we run again, we can go northwest. Sounds good. So at this point here, yeah, I want to kind of get rid of all of this stuff, because I can probably just kind of get it, because I can get this child number, and that can be object child. So the thing that I'm doing, it might make the code simpler, but it does make the code path a bit more complex, because each time it calls one of these helper functions, it's actually doing these header checks, and potentially over asserting itself, doing various checks. But eh, it is what it is. So here we can probably get rid of these two things before I forget. And we can do something like this. And here we want to do object set sibling, and we are setting the sibling for object number, and we're going to give it this child number. We can potentially even do something like this. How long is that? That's not too long. Something like that, and then we want to object set child of now we need to give it some machine and destination number, and we want to set it to be object number, and we also want to set the parent of object number, and we want to set it to be destination number, and I think doing that can get rid of all of that, and makes that whole thing fit in what, 23 lines. Refactoring, and if we do a quick check, we can still do things. We can see how far we can get. What if we go further back? Oh yeah, we can go. Can we go down? Yeah. Oh, we can go to the rainbow. I think it's like northeast from here. We can't go that far. Cool. No, that's like real cool. So if we add in that skip comment, refactor. It's just a refactor. And needed to do that because I did a reboot, so that's that. So I think that is probably good for this video. It basically achieved what I wanted to achieve, and now I think I'm just back to the tedious task of kind of implementing new instructions as they come. When I get something a bit more cool, I will probably do a video, but until then, thank you very much for watching, and if you like it, let me know. And until next time, see ya.